Well, hello again, sixth graders. Let's think about how we divide multi-digit whole numbers and decimal numbers. So remember, we want to activate some thinking. We want to use some standard skills by the end of this, and so activate some prior knowledge, and then think ahead to what's coming. Some vocabulary I want you to think about, again, is algorithm and quotient. When have you heard quotient before? What do you think that means? And bringing that information to class. Very important to pause here and write down what you do know or what you think you know, and providing that information for our discussions in class. What's happening when we divide numbers? What does it mean if I say 20 divided by 2? What am I really saying? Maybe even consider, what is that the opposite of? A lot of times we all get freaked out about divide, but if we really think about what it's paired with, it becomes a little less overwhelming. And then how does moving a decimal point change the value of a number? Meaning if I had 20 and I change that to 2, I move that decimal that you can't see right now, right there. What did I really do? And then how does that change the value of a number? How might it change it when I use it to operate? Kind of a loaded question, but write down what you're thinking. Maybe an example you come up with to illustrate for your classmates. So maybe if you didn't recall in the last slide, what you might recall now is that division is really repeated subtraction. We talked about multiplying being repeated addition, adding and subtracting are opposites, are inverse operations. Multiplying and dividing are also inverse operations. So when you see here, when I say 15 divided by 3, I can say I could subtract 3 from 15 5 times before I get to that 0. So if I'm at 15, I can repeatedly subtract the same number to get back to an even 0 there. Okay, so these represent the same thing. So stop and try that maybe with your own number. Pause here and think about, what do I notice? What do I wonder? Write that down before you move on. Right now you should be activating a lot of prior skills from several grades because math builds on itself and you do know a lot. So long division. Let's try some of these. This would be a good place to start, right? So I know that I'm really wondering, how many times does 4 fit into 356? Okay, so always know that that first number goes in the house, okay? Think about a rainstorm. They're running in here. So that first number and then the second goes on the outside. That's something I see often. And you're really wondering, how many times can this get in there? So you start with that first number. And again, remembering, we know 356 is really 3 100s, 5 10s, and 6 1s. Okay, if that helps you. But the weird thing about division is you start from the beginning. So I'm saying, well, 4 doesn't go into 3. So I know we're not fitting in there at least 100 times. 4 is not going to go into 300 100 times. So then we jump over and we look at the next place value. We treat this as 35, even though we know it's 350. So we say 4 goes in there, and I use a multiplication chart. 4 goes into there 8 times. 8 times 4 is 32. So that means 4 times 80 would go into 320, but not quite 350. So then there are 30 left over. I say 3. Then I bring down that 1. So I have 30 and 6 1s, 36. Then I know that 4 goes into 36 9 whole times. 9 times 4 is exactly 36. And I have a remainder of 0. This just means that 356 divided by 4 is 89. Also, it means that 89 groups of 4 would give me 356. Remember, this video isn't so much about doing this quickly, but making sure you understand why it's done a certain way. If you feel comfortable, pause and try this next one. Otherwise, follow along. So I'm wondering how many times 9 goes into 3,825. So I know that 9 will not go into 3,000 evenly, so I put a 0 there. 9 goes into 38, and again, I know this is 3,800 at this point, but I'm treating them as singles because that's easier, and recognizing place value as I go. 9 times 4, I just was reminded that that's 36, so I know it goes in there and not more. So that's 36. So that means it would fit into 3,800 4 times with 200 left over. Bringing down my other place values, so that'd be 225. But I don't really need to bring down that 5 yet, do I? So that was kind of silly. Ignore that. Bring the next place down because that's the next place we're in right here, right? So 9 goes into 22 2 times for 18. There are 4 left over, and that's 4 tens in that spot. Then I bring down my next digit because that's where I am. And I know that 9 goes into 45 5 times exactly. No remainders. So those are whole numbers. With that, my answer would be 425. So if this was ringing a bell to you, maybe practice out writing steps. You might recognize that I was dividing. I was saying, how many times does it go in? And then I checked it with multiplication. Then I subtracted to find remainders, brought a digit down, and I repeated that cycle. So here would be a great spot for you to try it on your own, pause, and then come back and see if we did it correctly, and just look at all of my work and see where you might have went wrong. So feel free to pause if you'd like here and try on your own. So I have 1,856, and I'm curious as how many times 32 fits in there. 32 does not go into 1. It also doesn't go into 18. What that means is that 32 isn't fitting into 1,800, any 100 of times there, okay? So I continue on. Does 32 fit into 185? And again, I might have to do some multiplying on the side. I know it does because I'm thinking estimating wise. I know 30 times 5 would be 150. So I think it might be around then. So that's what I might try to start. So I do 32 times 5 and I get 160. So it could fit in there again. So this is my 6th attempt. Nope, that's too many. So I'm going to go with a 5 and I get 160. And so there's 25 left over. Bring down that 6. So again, I could do a prediction. I know 32, 3 times 8 gives me 24. So if I try an 8 to start some side work, right, nice and neat still, I'm going to try and I get, exactly 256. My estimate helps me and not just doing a guess and check and going all around. So then that's exactly none left over, meaning that 1,856, 32 fits in there 58 total times. All right, try that next one and come back and check. Here's some work that I did. I change the colors every now and again. Hopefully that's not too confusing. But you can see I had to do some checking with my multiplying on the side and then make an adjustment with how many times I thought it fit in there based on that. So these are the ones, friends, I want you to try, and I want you to bring these to class with your notes. This will be kind of the part that we're going to look at tomorrow. And so pause here and try these and bring those with you to class tomorrow. So if you want to continue on with your video, you can now. Otherwise, you'll have to finish it. If you want to keep this fresh for the next night, you can. Might just be easier to start thinking about it now while it's fresh. So if you can divide 93 divided by 3, I want you to think about what would happen to your quotient or your answer to a division problem if you change it to 93 divided by 30. What might that be? And even more so, what if you changed the 3 again and said 93 divided by 3/10? Thinking about what is different, what might change. I might look at this first one with you and really challenge you on the next one to think on your own. We might know that, well, this 93 is the same as 90 plus 3. And we know that 3 goes into here once, 3 goes in here 30 times. So our quotient would be 31, right? If you did it like that, and obviously showing it long division would be great also, right? Because we'd say, 3, we get 9, none left over. Bring down the 3, once, 3, none left over, right? Same thing. So we see our quotient there. How does that change when I say, what if we did 93, and how many times does 30 fit into it? We know 30 goes into 90, and we know it's not going to fit into 93 evenly. So what does that mean for us? And here's a little hint that you have a decimal right there. What does that mean for us, and what do you notice this changed by? And again, what do you notice this changed by? You might see the same digit, but they've changed maybe by a power of 10. So try those and think about what kind of conversations and questions you can bring with you. Same one, last thing, how would these be different? So if you can divide, whether in your head or long division, 125 divided by 25, how many times does this go in there? How could you take that information and look to see, well, how would it be different if I change this by a factor of 10? And how would it be if I changed both of them by a factor of 10? What would my quotient be? How might it be similar, and how might it be different? Please have some things written down here, and please bring those for a great conversation leading into dividing with decimals. And I hope you guys have an awesome day. Remember to go back and look over your notes. Check things, explain these to a friend if you can, rewatch any section of the video, try more practice problems if you need to. iExcel is always available. And don't forget to put these in your backpack so that you have them for class. See you soon.